This is the third episode of Flat Earth Strawman. A strawman is an intentionally misrepresented form of an interlocutor's argument, which is replaced for the actual argument because it's easier to defeat. Taking this approach in an argument is a fallacy called attacking a strawman. I will be doing the opposite, exposing the strawman, to reveal how it differs critically from the real argument and producing support for the real argument. Another definition of strawman is a person regarded as having no substance or integrity. So the title of this series serves two purposes, as it highlights how little substance there is to the Flat Earth movement, and the unprincipled charlatans who propagate it with dishonest tactics. Today we look again at my perspective, and two of his videos about the passage of time on a globe. A link to his videos are below, but I will play the relevant parts of the 13 minutes here. I'll admit up front that this topic is a low-hanging fruit, but I want to demonstrate just how poorly my perspective grasps the basic concepts. Starting on his first video.
Direction. It's important to understand that. It's 1 24-hour rotation is a 360 rotation. So if
he claims one 24-hour rotation is 360 degrees. Let's play that again, because that's the claim he makes throughout this entire video, and his base claim is what we're going to attack.
It's important to understand that. It's 1 24-hour rotation is a 360 rotation.
So he says one 24-hour rotation is a 360-degree rotation. That's the base claim for the entire video. If his claim is true, then after half a year, 12 p.m. would go from being the time of solar noon to the time of solar midnight.
So if you start out at midday, right, and as the Earth rotates and orbits around the Sun, your position will always be in the exact same position after each 24-hour rotation. And so on as you orbit around the.
Since we don't experience this on Earth, MP concludes that the Earth is not a globe. Jumping ahead to 3:30.
Time would swap over. Midday, midnight would swap over. So they'll tell you, no, this is because of sidereal days and solar days. Well, you cannot explain away this problem.
He briefly mentions sidereal days and solar days, but doesn't go into the difference and says you can't explain away the problem. If he actually went into the difference between a sidereal day and a solar day, it would destroy his argument. The second half of this video is just a repeat of the first half, but with the moon added. So let's go instead to his second video, starting at 1:30.
Why is, well, there are sidereal days and solar days. Solar days are the days that we see on the Sun. It's what you experience. And a sidereal day, in other words, the Earth rotates 1 extra degree each day. And this is just a number fits game. So.
Okay, so he mentions the sidereal day, and he says the Earth rotates 1 extra degree each day. I'll explain the difference between solar and sidereal days, but he's going to completely elide over this additional degree of rotation. And in fact, he's representing it incorrectly here because he doesn't really show the Earth having moved a significant way in its orbit around the Sun. And that's really where the sidereal versus solar day degree differential comes into play. And now we move to 2:40.
If I'm at point 0, right, above me is a new moon, above that is the Sun, and at nighttime you see the Milky Way galaxy. So when you see the Milky Way galaxy and it's new moon, right, what happens now 6 months later when you're on the other side? Well, if you're facing the Sun, the Milky Way galaxy will be on the other side of the Sun. In other words, you could never ever film a full moon with a Milky Way galaxy behind it. Yet.
So MP gets his stellar geography all wrong. The Milky Way galaxy is not some distant deep space object that exists in a single direction away from us like the Andromeda galaxy. The Milky Way galaxy is the galaxy in which the Earth exists. It can be seen to some degree all year round. We can't see the same part of it all year, but we can see parts of it all year. So 180 days after position 0 in his diagram, we indeed can see the Milky Way at night. just not the same part that we saw earlier. So now my rebuttal. A sidereal day is about 23 hours and 56 minutes. During this time, the Earth rotates 360 degrees, and the stars appear in the sky in the same places. Let me demonstrate that here. So here we have the sun, we have the Earth on one day, and then we have the Earth 23 hours and 56 minutes later, having rotated 360 degrees, and the dashed orange line here, the dotted orange line, is pointing in the same direction off at distant stars. You'll see that the Earth has gone about a degree in its orbit, and there is about a degree difference between the direction facing the stars and the direction facing the sun. Okay, so a sidereal day is 23 hours and 56 minutes. The difference between a sidereal day and a solar day is 4 minutes, and those 4 minutes per day add up over time. If you go out to look at the stars at 9 p.m. every Sunday, you'll notice the stars are about 15 degrees out of place 2 Sundays later. Another way of looking at this is that the stars you see at 9 p.m. this Sunday will be in those same places around 8 p.m. in 2 weeks' time. That's because the sky rotates at about 15 degrees per hour, and the stars are offset by 1 degree every 24 hours. So it takes about 15 days for the stars to appear 1 hour earlier. Here's the program Stellarium. What I'm going to do is I have it set to May 21st, 9 p.m. And I'm going to advance the sky by 1 day. We can see every day at the same time at 9 p.m., the stars are in slightly different places. Okay, we've gone a week. Okay, now we've gone about 2 weeks. The stars are in different places than they were tonight. I'm now going to advance by a sidereal day, not by a solar day, but by a sidereal day. So you'll see the clock in the bottom right. See how it's not going hour by hour, but it's going by just under 4 minutes from an hour. So 23 hours and 56 minutes later, 23 hours and 56 minutes later, 23 hours and 56 minutes later, and so on. So every sidereal day, the stars go back to their same location. So that's the difference between a sidereal day and a solar day. Now, a mean solar day is around 24 hours. During this time, the Earth rotates actually 361 degrees, or about there, and the sun appears in the sky more or less in the same place. The solar analemma is a great demonstration of the fact that the length of a solar day changes slightly every day, which is why we say a mean solar day, an average solar day, is 24 hours. The solar analemma shows the sun's position every 24 hours, or every multiple of 24 hours. Since the sun's position in the analemma moves not only up and down, but also side to side, this means that in 24 hours, sometimes the sun has gone less than 360 degrees, and sometimes more than 360 degrees. A mean solar day is about 4 minutes longer than a sidereal or a stellar day. During those 4 minutes, the Earth rotates about 1 degree more. Why does this happen? Because during the 24 hours, the Earth has gone about 1 degree in its orbit around the sun. You can see that the Earth has gone about 0.986 degrees in its orbit around the sun in the span of 24 hours. So in order for a place on the Earth to be facing the sun again, the Earth has to rotate another 0.986 degrees. Thus, a mean solar day is 24 hours, during which time the Earth rotates on its axis 361 degrees and moves in its orbit around the Sun about 1 degree. That 1 degree of orbital rotation counters the 361 degrees of axial rotation. From our perspective, the Sun appears to go about 360 degrees in 24 hours, because that's 361 minus 1. Finally, flat earthers often make false claims about seeing the same stars every night, but challenge them to point out the constellation Orion in June and July. I'm going to go to Stellarium. I'm going to find where the constellation Orion is today. There, you can see Orion is right there. I'm going to turn the atmosphere back on so that the sunlight interferes with my ability to see the stars. So we have the constellation Orion visible right here. And I'm going to go forward a few days. And as we get into June and July, we see that constellation Orion has set at night. Therefore, we can't see the constellation Orion, because in reality, the Sun is taking up the part of the sky where the constellation of Orion is. Therefore, we don't see the same stars every night. If you challenge a flat earther to find the constellation Orion in June or July, they'll probably refuse the challenge if they know it's good for them. An even simpler fact is that the Sun moves through the zodiac constellations. This means that the Sun prevents us from seeing at night whatever constellations the Sun is currently in or near. This itself is a defeater for the terrible flat Earth claim about seeing the same stars every night. Of course, we can see the same circumpolar stars every night, albeit in different orientations as each day goes by. But that's not a problem with the heliocentric model. On the contrary, it's predicted by it. Many flat earthers claim to understand the heliocentric model, which is why they claim to be able to debunk it. But as MP has shown us, he either doesn't understand it, or he has to present a false version of it in order to debunk it. So next time, flat earthers, if you're going to try to debunk the heliocentric model, argue against the real heliocentric model. Don't set up a straw man, because I'll knock it down faster than you can. This is Jeff, realistically speaking.